Hello, welcome back to the workshop. So in a couple of recent videos you saw me make an Atlas Lathe from some spare parts I got on eBay. You saw me make a stand for it. In a recent video you did not see, I installed the countershaft assembly. I made bracketry so we could use the original guards. I installed a VFD and I wired up a contactor. You didn't see that last video because after 2 days of filming it, I ran the memory card through the washing machine with my coveralls. So in today's video, I want to show you the results of that missing video. Then I want to install a low voltage system with a tachometer for the spindle. I want to wire in the 240, get the motor tested, make sure everything works, and then I want to make something with it. So if that interests you, stay tuned. We'll get started. But before I show you those changes I made, let's go back a week. There's not enough room here. I'm gonna have to move these shelves. Great. So I finally got this thing where I'm happy with its location. It took a lot of back and forth. I finally decided putting it in this corner was probably for the best. So before I do anything else, I want to paint this stand, get a fresh coat of gray paint on this, and then I want to bolt it to the floor so it doesn't move. So that's what we're going to do next. So I put 2 coats of Rust-Oleum paint on this stand. It's had a couple days to dry. It feels really nice. It looks really nice too. I'm super happy with how that turned out. The finish is much better than it was when I did it on the treadmill motor on the lathe. So now that that's done, there's one last thing to do before I really want to make something on this. I want to install the tachometer on the spindle. But before we do that, let's use that time travel thing again. I want to show you those changes I made from the missing video. This is the countershaft and the motor mount, and this is the stand I built. And what I did is I made a bracket with some gussets to support that. So I installed that down 1 inch and back about 4 inches from the body of the lathe. And that gave me a belt alignment there that's perpendicular to the machine, I mean. To support the guards, I made a column here out of 2-inch steel tubing. I bolted that column to the motor mount, and I did that to give me some adjustability. Also, when I mounted that motor mount bracket, I made it out of some of the square tubing, and I did that so I could run wiring through it, so I didn't have motor wiring kind of running around. I actually planned to run this wiring through it too, but when I was installing it, I realized I didn't quite have enough length, so it's routed like you see it. But what this does is it gives me a good solid place to mount the VFD and an emergency stop switch. This is the bracket I made. I made it out of some 3/16 inch steel. What I did is I scored it with a grinder and then I welded it and then I ground the welds, which is why you see a couple of imperfections. I made it like that because I wanted it to sort of match the style of the rest of the lathe. So most of the headstock's got some pretty soft curves, so I was going for that same look. It bolts to the bracket that would have originally held the guard, and then it also bolts to that sort of column I made that holds the VFD. And what this does is it makes everything really rigid. I've riveted the hinge to this plate, which is part of the column. This isn't the best, it's pretty sloppy, so I'll probably redo that. But for now it works. This is the contactor I'm using. It's the same one you saw me use on the mill build, and I actually mounted it in the electrical box the same way. So 240 volt comes into this junction box, It's tied into the contactor and then it runs back out to the VFD. This is the VFD I'm using. It's the same one you saw me use for the mill build. If you're looking for a VFD, this one is right at about $100 on Amazon. I've had 2 of them now and had really good luck with them. They're model XSY-AT1. I've seen them made by different manufacturers, but they always have this label. So the way it's wired is 240 volts comes in from the contactor into the supply side or the line side here, goes in through the VFD circuitry, and then these 3 wires are UVW. These go to the motor. I'm using a safety switch, and this is an emergency stop switch. It just gives me another way to shut the lathe down fast. This one is wired into pin X1. It effectively shorts that pin to ground when this button is pushed. That pin is programmable, so you set up its function in the firmware when you program it. But here's a quick look at it in operation. So F is frequency. Right now our target frequency is 0, so it means the lathe is not running. We can see other information. We can see RPM, so this is actual motor RPM. We can see amperage, and this is amperage draw of the motor. So let's start. I'm going to actually go to RPM, and I'm going to just dial in an RPM. Unfortunately, it doesn't display the target here, so we'll hit run. So right now that motor is spinning at 707 RPM. I don't know what the gear ratio is by the time it gets through the countershaft and to the spindle, but I'll calculate what that is and I'll put it on the screen so you know what the spindle speed is. But it works really well. Emergency stop shuts it down fairly quickly. So we're at 1740 RPM on the motor right now. It's pulling 1.5 amps. And that's a frequency of 60 Hertz, which is what our US power is. So this motor is running at 60 Hertz. If we turn that down, this is how it controls the motor, so it adjusts the frequency. So let's go back and see what RPM this is. So we're back to 773. How slow will it go? That's about as slow as it can go and still have any torque. But that's based on the gearing. So that motor is spinning at 226. The spindle is going much more slowly. So now that you're up to speed on the changes I made, let's warp back to the present and let's get that tachometer installed. This is the tachometer I'm using. It's one of those cheap Amazon tachometers. It was under 20 bucks. It came with a wire and a pickup sensor. This pickup sensor is magnetic, so I'm assuming that's a Hall effect sensor. What I want to do is I want to mount this tack in an electrical box, just like I did the emergency switch, and I want to put it up here where I've got good visibility to it when I'm running the lathe. It requires low voltage, so it's a 12 volt system, so it requires 12 volt to run. But I have this power supply that I bought for a 3D printer I made, but that project didn't ever really go anywhere. I'm thinking this will accept 220 input and it outputs 12 volts. So what I'm thinking is I can mount this power supply on the back side of the VFD here where it's out of the way. I can then run wires up from the contactor to supply it with 240 volts and then run the 12 volts out to supply power to that tack. That will also give me a 12 volt, a low power, low voltage subsystem on the lathe that maybe I can use for other things. There are these 2 bolts. I don't know what they're there for or what they held on the original lathe, but I'm going to make a bracket that uses those 2 bolts and then carries this pickup sensor. Here's how that bracket turned out. I did use those 2 back bolts to mount the plate. It comes up at a slight angle. I did that to clear the gears here. So now what I can do is I'm going to make a collar that'll fit over the shaft right here with a magnet in it. and as it spins, that magnet will run past the pickup and trigger the tack. I left a little material right here, and I also cut clearance so that when the door closes, it doesn't hit the bracket. This bit of material I left, I'm going to drill a hole and use a zip tie to hold this in place so that I don't have to worry about that cord getting caught in anything. But where it is now, that bracket is such that the pickup is cleared by both guards. I'm pretty happy with it, but then you probably knew that already. So I think that turned out really nicely. Now I'm going to make the collar to fit over the spindle here, put a magnet in it, and then we'll wire this up and test it. I decided the quickest way to do this is to use the 3D printer. I designed a collar that fits between the gear and the bearing retainer. I added a groove for an O-ring that will compress when it's installed and keep this from spinning. And then I added a hole for an 8mm magnet. This one's printed out of carbon fiber PLA. I use that because it's what was in the printer. I will remake this out of brass or aluminum once I know it works. I'm going to epoxy a magnet in place here. And then the O-ring is going to give something to crush in place and hold it so it doesn't spin. I made it to where it fit on there tightly enough that it would go on and I wouldn't have to worry too much about rotation. But I also made it so that it sits inward of this bearing retainer. And the reason I did that is I don't want this to be a preload surface. The manual said 2 to 3 millimeters between the magnet and the pickup. And I've sized this so that I have 2 millimeters. So I mounted that power supply on a bracket I made. This is just a piece of 16 gauge steel. I bent the top over to provide some protection from chips. And I drilled holes, and I'm going to just mount it using those same holes that hold the VFD on. I'm going to mount the tack right in the middle of one of these weatherproof box covers. So I think what I'll do is I'll just drill 4 holes and then I'll use a jigsaw to cut between them to make it square. Actually, I take that back. I think I'm going to mount this up in the mill and mill it out. So that worked out pretty well. I extended the cuts a little bit to clear these corners, and then I took out some material on the inside so that these snaps would snap in place. And now it fits really well in there, see? So I'm going to mount it in this weatherproof box, and then I'll show you how I'm going to mount this box to the lathe. So this is kind of a happy accident. It wasn't intentional, but since I've got this bent over here anyway, I'm thinking I'll drill a couple holes and I'll just bolt this directly to that. It should provide a decent enough mount. I mean, it's pretty sturdy. So I drilled 2 holes in the top of the bracket, and I drilled 2 holes in the bottom of the box. And I found these aluminum spacers that I bought for a fuel injection project that you guys haven't seen yet. What I'm going to do is I'm going to install a bolt and then those spacers, and that will raise this up off of this bracket a bit. So according to these instructions, red is DC positive, black is DC negative, and yellow is the signal wire. And then on the pickup sensor, brown is positive, blue is negative, and black is the signal wire. So it's going to be brown and red to DC positive, blue and black to DC negative, and then black out of the pickup sensor to yellow on this. So let's get that wired. Alright, that's all wired up. Alright, so I've got the power supply wired into the 240. It comes in from the contactor into the power supply. And then I've got the tach signal coming in from the pickup sensor. And I've got the tach wired into the 12 volt. I don't yet have the magnet for the sensor, so I'm waiting on that from Amazon. So we won't be able to test that part. But let's at least turn it on and see if this works. Here goes everything. Hey, I forgot I got a green one. So we've got power, that's a good thing. I'm going to take a magnet, I'm going to pass it in front of that pickup and see if I can get it to trigger. Awesome. So that means our power to the tach is good. That also means our pickup sensor is working and wired correctly. And I'm just using a magnet here and I'm waving it near the pickup sensor. So once I get the real magnet, I'll epoxy it in here. We'll fire it up and we'll see if it works. But so far so good. The magnets I ordered came. I got way too many of them. The instructions for that pickup note that their magnets need to be the south pole. It's magnetic specific. It's pole specific. So I tried it on the machine and I marked the south pole with some blue paint so I get this in the right way. If it's in the wrong way, it won't trigger the pickup. I then sanded it a little bit to remove the shine, and I scuffed the inside of my collar as well. I'm going to mix up some epoxy and I'm going to glue the magnet into the ring. So I designed it with that magnet offset, so I'm going to install it O-ring side in. That shifts the magnet slightly out to better align with the pickup. Alright, let's see if that works. We're on. That looks like it works. So right now this is showing that the motor is spinning at 579 RPM and the spindle at 200. I don't know what that's about, but it looks like it's working pretty good. I'll bring the camera around. I want to show you what this looks like all assembled, give you a better view of that pickup and the magnet. Here's a better look at that all together. So this is a bracket I made. The pickup sensor is bolted into that bracket. And then this right here is that collar I made. And you can see the magnet is glued into a slot there. As that magnet rolls around, it rolls in front of that pickup. And that magnet rolling in front of that pickup is what sends the signal for 1 revolution to the tach. And it all fits in here really nicely. I'm pretty happy with how that all turned out. I think it looks of appropriate quality. So now that everything is done, it all works, it works really well. This lathe is ready to use. So now we can make something with it. This is my motorcycle helmet. Its visor is held on with these special screws. I lost one on a ride a couple months ago. I'm thinking maybe a good first project for this lathe would be to try and replicate or maybe make new screws for this visor so that I can have a matching set. So that screw is effectively, it's a 6mm bolt with a really large head. I'm thinking probably the best or easiest way to make this is to find a bolt with a head of similar size, a larger bolt, and then turn that down to match this diameter and then make the head match. So I'm going to go dig through my bolts bin and I'm going to see what I can find. I want to make 2 of them. I'm not going to replicate this exactly. I'm just going to make 2 that look the same, that are functionally equivalent. So here's what I found. There's the original bolt, and I found a pair of carriage bolts where the head is about the right size. Hopefully you can see that. So the first thing I'm going to do is I'm going to chuck this up and I'm going to turn these threads off and get this down to 6 millimeters outer diameter. If you dislike music over the top of lathe noises, well, don't worry, just for you, I put 30 seconds of unmodified lathe noise at the end of this video. So I made it about that far before it occurred to me that these are made of steel, and the first time they get wet they're going to rust. I don't know what it is, but it seems every time I go for a ride it rains, and I don't want to have rust running down the side of my visor, so I'm not going to finish these. That's as far as I'm going to take that. I'm going to get some stainless steel bolts and I'll remake these. This was a good project though for testing out the Atlas Lathe. Overall I'm really happy with it. The compound is a little sticky. I've got to work on that, and I'd really like to make a big chip guard, keep chips from getting down in those shelves back there, but those will be future projects. Overall though, that VFD is awesome. I'm really thrilled with the tack. It was worth the effort it took to install it. The machine, the whole machine is working really well, especially for its age and considering, you know, that I pulled it together from parts, so I'm super thrilled with the whole thing. If you're subscribed to my channel, I want to say thank you guys. I just recently hit the 1,000 subscriber mark, and that is monumental, and it's all because of you guys. So I want to say thank you. If you're not subscribed, I put out stuff like this just about every week. So, you know, consider subscribing if you want to see more of this. And with that, guys, I'm going to wrap this video up. Thanks for watching.